Volcanoes, lots and lots of volcanoes. Earthquakes, tsunamis, meteor impacts, a molten surface, a toxic atmosphere, and an ocean that was both boiling and freezing. Earth had been through hell. That was the Hadean Eon. But now things were calming down and the stage was set for life to appear. Welcome to the Archean Eon, the second chapter in the story of our planet. This is the first of 5 parts. Let's start with a quick recap. Our story begins at the formation of Earth 4.6 billion years ago. Over hundreds of millions of years, Earth grew from a hot, molten ball of rock to a world with a solid surface. We call this time period the Hadean Eon, which lasted from 4.6 to 4 billion years ago. Conditions were wild. But as the intense bombardment of asteroids and comets slowed, things began to cool down, at least a little. And we entered the Archean Eon, which lasted from 4 to 2.5 billion years ago. And this is our first glimpse of a more familiar Earth. Okay, maybe not that familiar. The name Archean comes from the Greek word for ancient. And ancient it is. This eon spanned 2 billion years, which makes it the longest period in Earth's history so far. So much happened during the Archean, but let's go through it chronologically. First up, the first continents. What? Yes, really. You heard me right. For the first time, solid land began to endure. The first bits of continent, called cratons, emerged from the ocean. Cratons are the rocky cores of continents that remain even after billions of years of erosion and rebuilding. Today, these ancient cratons form the foundation of today's continents, and some of them still survive, such as the parts of Africa and Australia. But hold on a second. Didn't the continents form when Earth was molten? Well, yes, they did. But what I'm referring to as continents are these ancient cratons. Now imagine you're a scientist studying rocks. How would you tell how old they were? You'd look for signs of erosion or burial by younger layers of rock. But if a layer of rock has been constantly exposed to wind, rain, ice, and heat for billions of years, well, then you've got a problem. How do you decipher its age? In some cases, scientists can look for magnetic signatures within the rocks themselves, and in other cases, they compare the chemistry of the rock to rocks of known age. By studying the ratios of certain elements, they can estimate the rock's age. Using these methods and others, geologists have been able to identify the oldest known pieces of Earth's crust. And what do you know? Some of them are more than 4 billion years old. These ancient rocks are the foundation of the modern continents, and they formed during the Archean, a restless planet. Beneath the surface, Earth's interior was alive with heat. Volcanoes reshaped the land, and the early stirrings of plate tectonics may have begun. Land was created, destroyed, and reborn as the young planet searched for balance. The first life. In the oceans, something extraordinary was unfolding. Life appeared, and it flourished. The first life forms were single-celled organisms called prokaryotes. Unlike today's cells, they lacked a nucleus and other internal structures. The most common and long-lasting type of prokaryote is bacteria. But another group, the archaea, also arose during the Archean. For a long time, scientists grouped bacteria and archaea together as a whole, simply called prokaryotes. But as our understanding grew, we split them into 2 separate domains of life. Today, we think all life on Earth falls into 3 domains: bacteria, archaea, and eukarya, which includes all organisms with cells that have a nucleus, like plants and animals. How do we know what kinds of life existed during the Archean? Because many early organisms were soft-bodied, their remains rarely fossilized, but some life forms did leave their mark on the rocks. One of the best-known fossils from the Archean are the Stromatolites. These structures were formed by colonies of photosynthetic bacteria called cyanobacteria. They lived in shallow waters where they trapped and bound grains of sediment, creating layered structures that are visible even today. The oldest known stromatolites are about 3.5 billion years old, an alien sky and sea. The Archean atmosphere was nothing like today's. It was thick with methane and carbon dioxide with no oxygen to breathe. The skies may have been hazy and orange, and the oceans shimmered green and iron-rich. But the young sun was dim. It wasn't until life began to flourish that oxygen started to fill the atmosphere. The revolution of photosynthesis. During the Archean, cyanobacteria discovered a new way to harness sunlight called oxygenic photosynthesis. As a result, they could thrive in the shallows where light was abundant. And as they photosynthesized, they released oxygen as a waste product. At first, this oxygen was absorbed by iron in the seas, forming vast banded iron deposits. But in time, the stage was being set for one of the greatest transformations in Earth's history, the rise of oxygen. Earth's childhood. The Archean Eon was Earth's childhood. Continents grew, oceans stabilized, life appeared and began reshaping the very air. Though the world was strange, alien skies above and microbial colonies below, it was here that Earth took its first steps toward the planet we know today. Next time, we'll enter the Proterozoic Eon, an age of transformation where oxygen would rise and the path toward complex life would begin. Thanks for coming along on this journey through deep time. If you want to learn more about our planet's wild history, there's a link in the description to a playlist with more videos like this one. See you next time.